Today we're talking about graphing with slope-intercept form. And to begin with, I'd like to review what slope is so that we can later use it for our graphs and in our equations. If you already have a really good handle on slope, you can fast forward a little bit. Slope is defined as rise over run, otherwise known as change in y over change in x. But just knowing the definition of slope isn't enough. The part that most students struggle with is the fact that slope is a direction and not a place. I have many students that when they look at the slope, they try to graph it just like they would a point, and that's not how slope works. Slope works just like if I ask someone to walk 5 steps north, then 3 steps west. They would walk 5 steps north in one direction and then go 3 steps in another direction. Slope works exactly that same way, just to a graph. Slope can be positive or it can be negative. If I have a positive slope, then my line is heading in more of an upward motion. And if I have a negative slope, my line is going to be headed in a downward motion. The run of a slope always moves to the right. There are exceptions to that rule, but it's very rare and it only happens when you don't have enough space on your graph. And that doesn't happen very often, so the run, let's just say, always moves to the right. Let's take a slope of 2/5. There's 3 things about this slope that we need to pay attention to. First of all, it's positive. Remember, positive slopes move in an upward motion. It has a rise of 2 and a run of 5, right? Rise over run. That means that this slope gives us 2 directions to go in. This slope tells us to go up 2 units and to the right 5 units. A slope of -7/3 is negative, has a rise of -7. Anytime you have a negative slope, make sure that it goes with your rise and never with your run. So it has a rise of -7 and a run of 3. So the 2 directions that this slope is going to give us is down 7, because a negative slope goes down, and a run always goes to the right. So down 7, right 3. A slope that's a whole number, like 2, needs to be changed into a fraction. Since the definition of slope is a fraction, we need to always think of our slopes as a fraction. So a slope of 2, I'm going to change that into the fraction 2/1. It's positive, it has a rise of 2 and a run of 1, so the 2 directions that this slope is giving us is up 2, right 1. Now, we're going to start with the equation y equals 2x, and before we work on how to graph, we're going to start with what this graph actually looks like. Here's the graph of the equation y equals 2x. Now, before we get any further, I want to bring up just a couple of things about this graph. Our x and y axes create a grid system that we've always learned to graph on, right? Well, this blue line that we just put on this graph occasionally crosses over that grid, right? There are points on this graph where I can tell what the point is, like here at 0, 0, here at 1, 2, here at 2, 4, but the points in between, I can't really tell with complete accuracy what those points are. Well, slope has to do with the points where this blue line actually crosses the grid itself. This line from one point on the grid to the next point on the grid goes up 2 units and to the right 1 unit. from one point on the grid to the next. That's where our slope comes into play. That slope is physically telling us from one point to the next point on the grid how far I go up or down and how far I go to the right. So this line has a slope of 2, and of course you see the 2 physically in the equation as the coefficient in front of our x variable. If I were to graph the equation y equals 2x plus 3, that plus 3 on the end actually translates our line up 3 units. It takes the whole line and moves it up 3 units. Couple of questions for you. What happens to our slope? What's the slope of our new line? Well, did the direction of the line change or just the position of the line? It was only the position that changed. Our slope is actually exactly the same. We still have a slope of 2. And you can still see the slope of 2 in our equation. The only thing that changed was that our new line crosses the y-axis at positive 3, where our old line crossed the y-axis at 0. That's the only difference between these two lines. Parallel lines move in the exact same direction and will always have the same slope. So we need to make sure that we understand that the number where the line crosses the y-axis is called the y-intercept, and I'm sure you've probably used intercepts in the past, so this shouldn't be anything new. Let's take a look at one more graph. This time let's graph y equals negative 1/2 x. Negative 1/2 is an important value to us because that's going to be our slope. Here's a picture of that graph. Again, there's points where this line crosses the actual grid and then points in between where I can't tell exactly what those points are. I can get close, but they're just not exact. The slope of negative 1/2 says from one point on the grid to the next, this line goes down 1 unit thanks to our negative slope, and to the right 2 units. Down 1, right 2. That's what a slope of negative 1/2 says about our line. If I were to graph a new line using that same y equals negative 1/2 x, but now I put a negative 4 or minus 4 on the end, that's going to translate our line down 4 units so that our new y-intercept is down here at negative 4. Still has the exact same slope, right? Still moving in the same direction. So what's our new slope? It's still negative 1/2. But what's my new y-intercept when I put the minus 4 on the end? Well, my y-intercept is at negative 4. So we have an equation, a general form for an equation of a linear line that's called slope-intercept form. Because this equation, once you look at it, physically tells you your slope and tells you your y-intercept. M, our coefficient on the x term, stands for slope, and B, what's being added at the end of our equation, is the y-intercept. The x and y variables in our equation stand for all points on the line, and since every point has an x coordinate and a y coordinate, that's where our x and our y values come in. So let's take a look at the equation y equals 7/3 x minus 5. Just looking at this equation, can you tell what the slope is? You bet, our slope is 7/3. It's always the coefficient in front of the x. I want to just bring up really quickly, notice that the y is isolated, and that's really important in slope-intercept form. If the y is not isolated, I don't have slope-intercept form. So our slope is 7/3, and what's the y-intercept in this case? -5, right? -5 on the end means my y-intercept is -5. So now let's go the other way and let's actually graph this equation. We're going to start with a point at -5 at our y-intercept. It's important when graphing with slope-intercept form to always start with the y-intercept. Then I'm going to take a copy of that point, and from that point my slope is 7/3. It's positive, so I'm going to go up and then right, and this tells me to go up 1, 2, 3, 4, 5, 6, 7 units, and to the right 1, 2, 3 units, and that's where my next point is going to be. I'm already seeing where my line is going to go, but just to be safe, I'm going to copy that process, and I'm going to take a copy of that point again, and I'm going to go up 1, 2, 3, 4, 5, 6, 7 units, to the right 1, 2, 3 units. Now I have a really good indication of where my line is supposed to go. So let's draw in the line going through the points. I'm going to extend that line so that it goes all the way across my graph. The easiest way to do that is using a straight edge and a pencil. And I've graphed the line y equals 7/3 x minus 5. No problem. Let's try that one more time. Let's graph y equals -5/2 x plus 4. First of all, we need to identify the slope. And in this case, the slope is -5/2. The negative says that we're going to go down, and the slope, the fraction part of the slope, says we're going to go down 5 units and to the right 2 units. The y-intercept, according to this equation, is +4, right? We're adding 4 to the end of our equation. Now let's graph, and of course we always start with a y-intercept. In this case, the y-intercept is +4, so that's where I'm going to start, on the y-axis. Remember to always start on the y-axis. Now since my slope says to go down 5 units and to the right 2 units, I'm going to take a copy of that point and do just that. From my y-intercept, I'm going to go down 1, 2, 3, 4, 5 units, and to the right 1, 2 units. Then I'm going to copy that process, or repeat that process, go down 1, 2, 3, 4, 5 units, and to the right 2 units. Then of course I'm going to draw in my line. I would generally use a straight edge and a pencil to do this. Make sure the line goes all the way across the graph. And now we have the graph representation, or picture representation, of the linear equation y equals -5/2 x plus 4. Okay, I think that's enough for today. Remember, when graphing with slope-intercept form, make sure that y is isolated, that it's actually in slope-intercept form. Then start with the y-intercept, and then use the slope to tell you what direction you should go from there. For now, I'm going to wish you a very good day, and I'll see you next time.